Hi, I'm Bob. Welcome to our Econometrics tutorials that focus on fundamental econometric concepts, estimation methods, and identification strategies. Today, I will provide a roadmap for learning econometrics and an overview of what we will explore in this course. An introductory course in econometrics consists of two key components. The first component focuses on OLS regression analysis. It covers basic concepts and models applied to three major data structures. We start with cross-sectional data. The cross-sectional dataset consists of a sample of individuals, families, firms, and cities that are observed at a single point in time. For example, consider a dataset containing information about the U.S. workers. The data were collected in the year 2017. Each observation is for one worker. For cross-sectional data, we use the ordinary least squares (OLS) method to estimate parameters. We will explore regression models with both single and multiple explanatory variables. The properties of OLS estimates will be examined with a focus on the OLS fit values and residuals. In addition, we will discuss the interpretation of OLS estimates. We will also investigate the assumptions underlying OLS and the Gauss-Markov theorem. Next, we will explore linear hypothesis testing for a single population parameter or a linear combination of parameters using the t-test and f-test. We will encounter basic concepts like the goodness of fit, R-squared, and p-value, alongside discussions on functional forms and dummy variables. The second data structure is time series data, which contains information for a single individual, firm, or country over multiple time periods. For example, consider a dataset of the Consumer Price Index (CPI) for all urban consumers from 1947 to 2025. The data were released monthly. The dataset comprises 940 observations, all from a single country, the United States. A key characteristic of time series data is the time dimension, which is indicated by a time variable, such as the observation date in this dataset. While we continue to apply the OLS method to time series data, we will learn concepts specific to time series, such as serial correlation, unit roots, and co-integration. The third data structure is panel data, which combines elements of both cross-sectional data and time series data. A panel dataset consists of time series observations for multiple cross-sectional units, meaning that the same individuals, firms, or countries are observed over multiple time periods. For instance, consider a dataset containing information on U.S. workers, where each worker is identified by an ID variable, and each time period is marked by a year variable, representing both the individual and time dimensions. To estimate coefficients for panel data, we employed 6 key approaches to adjust unobserved heterogeneity, alleviate bias, and improve estimation accuracy. Pooled OLS, treating panel data as a large cross-sectional dataset without accounting for individual fixed effects. Random effects. Assuming individual specific effects are random and uncorrelated with explanatory variables. First, differencing. Eliminating individual fixed effects by differencing consecutive observations within groups. Within transformation fixed effects. Using deviations from individual means to estimate, accounting for time-invariant individual characteristics. Dummy variable fixed effects. Using dummy variables to control for individual fixed effects or time fixed effects. Correlated random effects. Accounting for correlation between individual fixed effects and explanatory variables. The second component of Econometrics focuses on identification challenges and estimation methods. One of the primary objectives of econometric analysis is to estimate the causal relationship between variables. However, an observed association between two variables does not necessarily imply causality. The goal of econometric analysis is to identify and estimate causality rather than merely finding association. An obstacle to achieving this is endogeneity, which arises when relevant factors are not held constant, resulting in biased or inconsistent OLS estimates. Endogeneity occurs when explanatory variables in the model are influenced by factors relevant to the study but not controlled for within the model. We will explore sources of endogeneity, which include omitted variables, relevant factors that affect both the explanatory and outcome variables but are excluded from the model. Reverse causality. Situations where the outcome variable may also influence the explanatory variable, creating a two-way process. Sample selection. The sample may not accurately represent the population of interest, leading to systematic differences that can distort results. Measurement errors. Most survey data are retrospective, and respondents may not provide accurate information, which can affect variable reliability. And simultaneity. Each of these identification challenges will be examined in detail, and we will develop estimation methods and identification strategies to effectively address endogeneity issues. These remedies include instrumental variables and two-stage least squares. Use instrumental variables that are correlated with the endogenous explanatory variable but uncorrelated with the error term to estimate in two stages. Difference in differences. A technique for causal inference, controlling for unobserved factors. Heckman two-step procedure. Correct sample selection bias by performing a selection regression in the first step and then include the selection variable in the second step. Throughout our study of econometrics, we will explore various models, including simple regression model, multiple regression models, simultaneous equations models, limited dependent variable models, linear probability models, two-bit models, pro-bit models, infinite distributed lag models, random effects models, and fixed effects models, among others. Mastering all these models may seem like a daunting challenge, but don't worry. Just like building a tower, We will accumulate blocks slowly and steadily, reaching our goal step by step. I will use real-life examples to illustrate econometric models and estimation approaches. I hope it will help you better understand econometrics and use modern econometric methods in your daily life and research. Thank you very much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.